Welcome. In this session, we give more examples on how to apply the linearity property of Laplace transforms. So let's see the examples. So the example is, find the Laplace transform of the following functions. So the first part of the first question, 5 cos of 3t plus 2 sine of 5t, then minus 6 t power 3. Now to solve this solution, so Laplace transform of 5 cosine of 3t plus 2 sine of 5t minus 6 t cubed is the same as Laplace transform of 5 cosine of 3t plus Laplace transform of 2 sine of 5t plus Laplace transform minus 6 t power 3. The second part of the linearity property, we can write this one as 5 Laplace transform of cosine of 3t plus twice Laplace transform of sine 5t, then minus 6 Laplace transform of t power 3. Then we know that Laplace transform of cosine of bt from Laplace transform tables is given by s over s squared plus b squared. Laplace transform of sine of bt is given by b over s squared plus b squared, and Laplace transform of t power 3 is given by t power n is given by n factorial over s raised power n plus 1. Now in this case, first part, the Laplace transform of, so Laplace transform of cosine of 3t will be given by, so we replace b by 3, so it will be s over s squared plus 3 squared, which is s over s squared plus 9, and then Laplace transform of sine of 5t. So when you relate to this one, you know b is 5, so it will be 5 over s squared plus 5 squared, which is 5 over s squared plus 25. And then Laplace transform of t cubed. Now n is 3, so it will be 3 factorial divided by s raised power 3 plus 1. 3 factorial is 6 over s power 4. So replacing these values, if I call this, all this star, and I call this equation, call it 1. So replacing star in 1, we get Laplace transform of 5 cos of 3t plus 2 sine of 5t minus 6t cubed will be given by 5 times s over s squared plus 9 plus 2 into 5 over s squared plus 25, then minus 6 into 6 over s power 4. On simplifying, we get 5s divided by s squared plus 9 plus 10 over s squared plus 25, and then minus 36 over s power 4. So that will give us the value of the Laplace transform of that given function. And then b, we have the function minus e raised to power minus t plus a half into sine of t plus cosine of t. Now to evaluate this, we first say Laplace transform of minus e raised to power minus t will be Laplace transform of minus e raised to power minus t plus Laplace transform of a half into sine t plus cosine of t. And then this is the same as, first one is the same as negative 1 Laplace transform of e raised to power minus t plus a half Laplace transform of sine of t plus cosine of t. Then we have minus 1 times Laplace transform of e raised to power minus t plus a half Laplace transform of sine of t, then plus a half Laplace transform of cosine of t. Just applying the linearity properties. And we know that Laplace transform of e raised to power minus at from Laplace transform tables is given by 1 over s plus a. So which means Laplace transform of e raised to power minus t will be, so in this case, a is 1. So this will be 1 over s plus 1. Then Laplace transform of sine of bt from Laplace transform tables is given by b over s squared plus b squared, which means Laplace transform of sine of t. Now be the same as 1 times t, so b is 1. So this will be given by 1 over s squared plus 1 squared, which is just 1. And then Laplace transform of cosine of bt from Laplace transform tables is given by s over s squared plus b squared, which means Laplace transform of cosine of t, b is 1, so it will be s over s squared plus 1 squared and just write 1 squared is the same as s over s squared plus 1. Or this you could have just said this one, which means 1 over s squared plus 1. So if I call this step, I call this one equation 1, and I call all this star, then I say putting star in 1, we have Laplace transform of the function minus e minus t plus a half into sine t plus cos t will be, so this will be negative 1 times the value of this transform is 1 over s plus 1 plus a half value of the transform of sine t is 1 over s squared plus 1, and then plus a half Laplace transform of cosine of t. The answer is s over s squared plus 1. So which means the answer will be negative 1 s plus 1 plus 1 over 2 into s squared plus 1, and then plus s over 2 into s squared plus 1. Now these last two terms have the same denominator, so this we can write this one as minus 1 over s plus 1 plus 2 into s squared plus 1, and then 1 plus s. So therefore that is the answer to that given problem. Thank you.